This video is about relational data model, and the learning objectives of this video are to learn about the relational model's basic component, which is the relations, and how the relations can be implemented as table in a relational DBMS. By the way, Oracle is a relational DBMS. And we're also going to look into the relational database operators, the data dictionary, and system catalog. We're going to talk about data redundancy and how it can be handled in the relational data model. And finally, we will discuss about the importance of indexing certain fields. So what is a logical view of data? Now, a logical view of data refers to how the user perceive or see the data. So it is designed to suit the need of different users by representing data in a meaningful format. And this can be done using relational database model, which you will hear me talking about this term called RDM. And RDM enables logical representation of data and its relationship. RDM simply provides a very effective database design methodologies, as you can see later, and the data and its relationships are stored in relations. Now, a relation is basically a relational table, and every relational table has certain characteristics. As you can see here, there are 8. So, for example, every or each table row, also known as tuple, represents a single entity occurrence within the entity set. Now, an entity set can be seen as a table, and the single entity occurrence is seen as a record. So a table can have many records, and so an entity set can have many entity occurrence. Alright. Now the other one that I would like to highlight is the attribute domain. So what does that mean? That basically refers to a specific range of values. So if I have defined a field, and this field is numeric 4, 2, remember what we have done in the lab? Numeric 4 or number 4, 2, basically it has got 4 digits and 2 decimals. So here you can have values from 0 all the way to 99.99. So that's what I call a range, and this is the attribute domain. Now the other very important characteristic of a relational table is this one. Now it says each table must have an attribute or a combination of attributes that uniquely identifies each row. So in other words, we have to make sure that we are able to pick one field or several fields, combination of several fields, and that value is unique. In other words, you cannot see another same value repeated within the same table. So this is one of the characteristics that we must fulfill in every relational table. So let's take a look at this example, the student table now. This table has got 1, 2, 3, 4, 5, 6, whatever. Alright, quite a number of fields there. So this is what I call column, or you call it field, alright, or attribute. Alright, so all these lines here, they are rows, or you call it record, or tuple. Alright, so there's nothing difficult here. Let's see, we can pick one here. Let's say I'm trying to illustrate to you the attribute domain. Alright, let's say, for example, professor number. Alright, now here professor number, you can see that it starts with 199 all the way to 311. So for all we know, alright, when the designer designed this particular student table with a field called prof number, it could have started with 100 and all the way to 999. So it could be integer 3 in this case. And so that's what I call the range of values, or we simply say attribute domain. Next, a very important concept in the relational data model is the key. So what do you understand by key? A key can be one or more attributes that determine other attributes. So in other words, it has to be a field that is uniquely able to identify other rows. Alright? And one of the examples of a key is what we call the primary key. So when I say a primary key, it has to be a field or a combination of fields that uniquely identifies any given row. So for example, if I define the student number as a primary key, then all the rows in this particular table for the student number, all the student number must be unique. You cannot have a repeat value. There are several types of keys, so let's take a look at the different terminologies. Now there is this term called composite key. A composite key is basically a key that has got one or more, that must be two or more attributes. Alright, so a key that is composed of more than one attribute. So for example, if I have a relation or a table called property, and this property table has got house number, street name, postcode, type, and price. So if I have to use a combination of three fields to make a primary key, this particular a combination of three fields here is what I call a primary key, which is also a composite key. Alright, and the key attribute, any one of these is known as a key attribute. So if I ask you for an example of a key attribute for this table, you can either say house number, street name, or postcode. Now there is this particular term called entity integrity. It is a situation or condition in which every row in the table has its own unique identity. So it's a very simple concept here. So if I say that this table exhibit, in other words, it follows entity integrity, that means that all the primary key values are unique. Alright? So it says all the values in the PK must be unique, and no key attribute in the primary key can contain null. Now in the lab we have talked about null already. Null basically means empty value. So if I define a field as a primary key, then that particular field cannot be null. So now, what does null mean? This is just a revision. Alright, absence of any data that could represent an unknown attribute value. So for example, date return. Now just imagine you go to the library to borrow a book, and you have borrowed a book and there is a due date for you, but you can return earlier. So in this case, if the library has created a field called date return in their database, obviously when you borrow the book, at that point in time, the date return will be null because it's unknown, because they do not know when you're going to return the book. Alright? So another example of a null could be that that particular attribute value is missing. It's not there. It is just not there. Or it is not applicable, and therefore that particular attribute value is empty or is not there at all. This slide shows us the number of keys that are available or we need to know in the relational database. You have got super key, candidate key, primary key, foreign key, secondary key. Primary key is something that I've just mentioned, and this primary key is a key which uniquely identifies a record, and it has got three main characteristics, which is unique, not null, and minimal. Super key is also a primary key, but in that it has got an additional attribute. So if primary key has got 3 fields, super key will have 3 plus 1 plus 2 and etc. So it has got more than that. Alright, that's why it also uniquely identifies the record. So they actually act the same way. So, but in our course, we will be focusing on primary key. Alright? Now, foreign key cannot stand on its own. It has to be derived from the primary key of another table. We will later take a look at some examples. So, candidate key here is all the possible primary keys. So, in a table, we may be able to identify at times several possible primary keys. So, in this case, those are all called candidate keys. Alright, so once I've chosen one of the keys as a PK, then the rest will be seen as a alternate key. Right, so secondary key is different from any of these. Secondary key, as it says there, is used for data retrieval purposes. So sometimes this is more like indexing. So it is nothing to uniquely identify a record. It is used for retrieval purposes. So it's for fast performance. Okay, now an example of a simple database, relational database. So let's say we have got 2 tables here. First table is called product and the second table is called vendor. Now by looking at this table with the data, we will make product code as a PK. Okay, a PK is a field or a combination of fields that uniquely identify a record. So you can see that all the values in the PK is unique. You don't see any of them repeats. Alright? And the same thing applies to the vendor table, where you have a vendor code, and the vendor code here is all unique. So that's the PK. Right, so we have got PK, vendor code as PK in the vendor table, and we have product code as PK in the product table. Now, assuming that these 2 tables has a relationship, they can join to each other. For example, a vendor can supply many products. Alright? So in this case, there will be a need for us to establish a link. So we will then use a foreign key. That's the purpose of a foreign key. A foreign key is for linking. So here, where do we know, or how should we establish a foreign key? Remember what I said earlier? Foreign key is foreign. So in other words, it is derived from the primary key of another table. So if you look at this product table, you can see that there is one field here called vendor code. Right now, this vendor code is what I see as, or I call it, a foreign key. This particular key is derived from the primary key of this table, and hence foreign key. Alright, so what the foreign key says here just now, alright, here it says an attribute or combination of attribute in one table whose value must either match the primary key in another table or be null. So in other words, if I have a foreign key and the values here, all these values must be found in this table. Alright, now you have one here called 234. 234 is not found here. That's okay, because as long as the foreign key values can be found in the primary key of this table, no issue. Either that, or let's say if I have a null value here, alright, instead of 235 is null, it is also okay, because null has got no effect. It does not violate the rule, alright, of this definition. What it says there, must either match the PK in another table or be null. So that is exactly what happens. So if it's null, no issue. So here is an example of keys, and I would like all of you now to take this time to analyze this hospital database. There are 4 relations here: patient, admission, doctor, and ward, and identify the PK and the foreign key. Alright, and we will discuss this shortly.